Okay, welcome back. This is question 5 in section 6.2, finding the volume using the washer and the disk methods. Again, we have two functions, both of them is in terms of y, so we have to sketch them in a special way. But since we have already seen how we sketch them before, will be a usual parabola, okay? And if we do the flip and the rotation, the final one will be look like this. The final graph would look like this, and it would go this way. Of course, you are welcome to try it by yourself. It's a good practice to try it. This one, it will be looking like this. And then the region is between them is this one. Okay. You can try how we sketch those two functions, but would be the final sketch. I'll just go through it here. And now the axis of revolution is the y-axis, so it will be this one here. This is the axis of revolution, and let me just write the function here. And the function here is x equal to minus y squared. Now, if we want to find the volume, we can do it in one quick step because now we get used to it. So the volume will be by integral, and then you need to find for me what is r out squared and what is rn squared dy. Now, in order to find the r out, we need to write an arrow from the axis of revolution to the maximum I can go inside the region. And this is r out. Now, how long is this arrow? Let's see. It will be right minus left. And right minus left, let me write it here so don't forget it. Same thing here. How much is the right function? It's clear as the blue one. So it is 2 minus y squared minus. And the left function is the 0 function, which is because this is y equal to 0. Oh, sorry, this is x equal to 0. So it's minus 0. Same thing we need to do for the nr. The nr will be from the axis of revolution to the nearest I can go inside the region. So it will be right minus left. Right is the green one, and the left is the red one. So it will be y power 4 minus the left one, which is 0. All what we need to do next is we need to find the limit of integration. And the limit of integration, we need to find the intersection points. Why the intersection point? Because look with me here. If you move r out maximum to the down, you will reach this point. And if you move it maximum up, you will reach this point. So you need to find the intersection points, and let me find them here. Maybe here. Let me just erase this. And let's do it here. Intersection points. Now the intersection point is where the two functions they meet. 2 minus y squared equal y power 4. And that's where they both meet. Now this is a tricky equation because this will be y power 4 plus y squared minus 2 equal to 0. If you try to factor it, it will be y squared and y squared, okay? and then it will be one of them plus and one of them plus 2. And minus 1. Now 2 brackets are equal to 0. Each one we make it equal to 0. This has no solution. You can try it at home in your calculator. The other direction, y squared minus 1 equal to 0, means y equal minus 1 and 1. So the only answers we get is minus 1 and 1, and those exactly matches our observation. One of them positive, one of them is negative. All what we need to do is we go back here and we write them down. Negative 1. So please, if you have any question, let me know. Just quick reminder of what we did. We start with two functions in terms of y. We sketch them using the method of sketching functions in terms of y, flip, and rotation. We find out our region is this one here, and the axis of revolution is a little bit far from it. We need to find r out, which is this one, from the axis of revolution to the maximum we can go inside. And to find r out, it's right minus left, so this minus this, blue minus red. And Rn is where we go from the axis of revolution to the nearest, which is the green function here. And finally, to find the intersection points, we need to solve the two equations which are equal, and the only way we can do it if we have two numbers, negative 1 and 1. Thank you for watching, and please let me know if you have any question in the comments.